Welcome back, everybody. Today we're continuing our look at congruent figures, specifically talking about proving triangles congruent. And we're going to do that by giving you two more shortcuts, two more ways we have of proving triangles congruent. The ASA as an angle-side angle, and the AAS as an angle-angle-side postulates. Objective to prove triangles congruent using the ASA and angle-angle-side. Let's get going with that. So first, let's talk about the angle-side angle postulate and show you why it works, basically. If I take a triangle in blue and make a copy of one of its angles, one of its sides, and another angle with the side between the angle, let's see what I'm left with here. When it comes time to make the rest of my triangle, I really don't have any options for what this angle can look like. It's fixed. Same thing for my other angle here. I can't choose different measures for that angle. They're fixed, which means that when I bring these together here, that third angle is fixed as well. Because if I know two angles of a triangle, we know the third one, subtract 2 from 180, your third one's stuck. Other thing is the side lengths I don't know are fixed as well. I can't make them any shorter. I can't make them any longer. They have to be long enough to meet up here. So moral of the story is that if I know the angle-side angle of the triangle, I know the rest of the triangle. Those two triangles have to match. All right, that is my angle-side angle postulate, or the ASA postulate. It just says that if two angles and the included side of one triangle are congruent to two angles and the included side of another triangle, then the triangles are congruent. So if I have angle-side angle, angle-side angle, again, where we'd say that that side is included between my two angles, the triangles are congruent, I get the rest of the parts, the angles and sides, for free. Now the angle-side angle postulate is going to lead us to the angle-angle-side theorem, the AAS theorem, which states that if two angles and the non-included side of one triangle are congruent to two angles and the corresponding non-included side of another triangle, then the triangles are congruent. So in other words, if we have angle, angle, side, we get the triangles congruent to each other. This one is a theorem, and I don't have a visual to kind of explain it for you because it'd be something we'd prove mathematically through equations rather than accepting it as a postulate. But it's a direct result of the angle-side angle postulate we gave you a minute ago. All right, so let's put those two new shortcuts to work. Problem 1, part A says which two triangles are congruent by angle-side angle. Now, this is a great problem to help you practice kind of visualizing and figuring out how these pieces, how these parts have to kind of come together on a triangle. So we're looking for the angle-side angle postulate. It looks like it's going to be the first triangle and the second triangle. They're going to match by angle-side angle. They both have angle-side angle, angle-side angle, with the side included between the angles. Whereas the third triangle, we do have two angles, but notice the side is not included between them. It's on the outside of those two angles. So that's why this one works. Now, rather than circling the triangle, we can talk about it with a congruent statement. So what I'm going to do is I'm going to say that triangle, let's say SUV, is congruent to triangle, we'll name the other triangle here. Now, when I'm writing a congruent statement, I can pick any order I want for the first triangle, but the second triangle has got to go in the corresponding order, as in, since I put S first in the first triangle, I need to find the angle that it corresponds with, in this case N. Both of these have no arches on them. So we'd say N. Next I did U. U has a single arch, so that'll correspond with E. V was last. V with the two arches, O. So there's many different congruent statements I could write, but once I pick the order for the first one, I've got to stay in the same order for the second triangle. All right, problem part B is the same idea. I want you to take a minute, pause the video, work through that one, and then hit play to check your answer. All right, so let's run through this one. Which two triangles are congruent by angle-side angle? Well, it looks like it's going to be the first one because we have that angle, side, angle set up, along with the third triangle, angle, side, angle. In the middle, once again, we have our side not included between the two angles. It's just outside of them. And then when it comes time to write the congruent statement, you might have something different than mine, because I can pick any order I want for the first triangle. We'll just go OGH. We'll say that's congruent to triangle, and it's staying in the same order, we'll say TCA, where each of my letters, okay, in order corresponding to the matching angle on the other triangle. All right, now problem 2 is going to be the big question for this section here. It asks, would you use side, 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 angle, angle, or angle, angle, side to prove the triangle is congruent? Or we could have not enough information. So basically what I want to do is I want to give you a bunch of different triangles here and mix all our different shortcuts together and make sure that we can tell the difference of when you'd use one as opposed to the other. Okay, so let's run through one together here quick. So I want to see if these two triangles on the left and right are congruent. Now what I'd recommend to do is actually write out what we know. Okay, put A for angle and S for side, okay, in the picture here. Now here I've got an angle on the left matching the angle on the right. We've got another set of corresponding angles that are congruent here and here. And then a trick we're going to see a bunch is, since these two triangles share a side here, that's a side that I know has to be congruent. So what do I have for this one? If I go around the triangle in order, we have angle, angle, side, where that side's outside of my two angles. So for this one I can use my fourth shortcut. We can say yes by AAS. Okay, there's a bunch more examples. I'd encourage you to pause the video, try to work through those on your own first, get some practice with this, and then click play and we'll run you through the rest of the examples. Alright, so going through these. B is pretty straightforward. Let's mark what we have. We've got an angle on each triangle. We're given another angle. And we're also given the third piece of information, the side. Okay, I suppose this one's a good one to show the difference between angle, side, angle, and angle, angle, side. This one will work by angle, angle, side if I stay in order. What I can't do with it is I can't say angle, side, skip an angle, skip a side, angle. Okay, we've got to keep things in order. So B is a yes by AAS. All right, part C, let's take a look at what we have. Now notice in C I have two right angles. Okay, they're not marked congruent to each other, but I know if they're right angles, they're both 90 degrees, therefore they're both congruent. So I am given angles here, angle, angle. I also have a set of sides that are marked congruent. And then the trick with this one is notice where these two triangles come together, we have a set of vertical angles. Okay, I know vertical angles are congruent, so there's my third piece, there's my other angle. So what I have then is angle, side, angle when I stay in order. So C is going to work. These triangles will be congruent by angle, side, angle. All right, part D, let's take a look at what we have. We have a set of sides marked congruent. We also have a pair of angles marked as congruent as well. And then once again, we see that we have two triangles matching up along a common side. So that will be a second side congruent. Okay, so what do I have here? Well, in order, I have side, angle, side. Therefore, these ones will work by SAS. Next up, E is pretty straightforward. We've got one set of sides. We have two sets of sides, and we have a third set of sides. Okay, we have all three sides, therefore we can say yes by SSS by the side, side, side postulate. All right, part F, let's take a look at what we have. We have a pair of sides we're given congruent, And then we're not given anything else explicitly here, but let's take a look at how this one works out. Now notice we have two angles that come together to form a straight angle. Okay, so we have a linear pair. And since one of them's 90, the other one has to be 90 as well. Okay, because 90 plus 90 would give us 180. So here we do have a set of angles. And then once again, like we've seen a few times, these triangles share a common side, so that's a second side we know. All right, so this one we can say is congruent by side angle side once again. All right, that's it for section 4-3. Hopefully it's pretty straightforward for you. Start working on the homework, start getting your practice in. We'll be here if you need help, and otherwise we'll see you later.